Hi, welcome to this video. If you are new to this channel, I encourage you to subscribe. And for those of us who are not first timers and keep coming, I'm very grateful. We are looking at the Shem Prashad Lead Code series, and currently we're on the 18th algorithm there, which is on the find smallest greater than target algorithm. So let's get into the video. So looking at the algorithm here, we are told that you are given an array of characters, letters, that is sorted, okay, in non-descending order, that means in an ascending order, and a character target. So we are given an array of characters, letters, and we are given a target, which is also a character. There are at least two different characters in letters. So in this array, we expect at least two different characters. And we are to return the smallest character in letters that is lexicographically greater than target. This just means that it's alphabetically more than the other. That means B is more than A, C is greater than B, and so on and so forth. So if such a character does not exist, we are to return the first character in letters. Okay, so we are given an example: C, F, G is in letters, and the target is A. And A does not exist here. So after A, the next one after A will be B, but B is not here. So C, and so C is what we pick. So that's why we have C here. Here we are given C, and C exists here. Okay, the next one after C, which is our target, the next after this target, which is C, is F. So it returns F. We have Z here, and we don't have Z at all here. So, and you know they said, if such a character does not exist, we have to return the first character in the letter. So since Z does not occur, and even after Z, the next character after Z, whatever it was, is not in this array. So it means we have to just return the first item in the array. So that basically, so we are told that the number of letters, okay, the length of the array will at least be 2, because we are told that there will be definitely at least 2 characters. So at least minimum there will be 2 characters, and can reach this. All lowercase. It is sorted in non-decreasing order. Okay. So basically this is what we are given. So let's try and see how we can come up with our algorithm here. So say we are given an array C, F, and let's say H, and we had the target character was A. So we could start from here, from the first character, and ask. So the question we'll be asking is, C, wherever we are, is it greater than the target? So C, is it greater than the target? Yes, it's more than the target. And so we stop there, because we know definitely this is the character we want to return, because you know what we have to return is the character that is greater than the target. So if A is the target, then and definitely C is going to be the next character after it. So definitely C is the answer. If, for example, we had C, F, and H, and we are given, let's say, K. So we start. Is C greater than K? No. So we move to the next. Is F greater than K? No. So we move to the next. Is H greater than K? So we move to the next, but that's the end of it. So since there is no available one, we have to return the first character, which will still be C. Alright, so let's say we have C, F, H, and then we are given, let's say, G. So C, is it greater than G? No. So we go to F. Is F greater than G? No. We go to H. Is H greater than G? Yes. So definitely this is what we have to return. H will be the response for this now. So basically you see that we just keep going through, because, and the reason why we can do this is because we know it is sorted. It's very important, is because this is, we are guaranteed that it is definitely going to be sorted. So this is the approach we could use. But you know, for this, it means if we have, for example, let's say A, B, C, D, K, 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 N. It means we will need to go through, for example, from here all the way to, and let's say our target was maybe, let's say, O, for example. It means we will have gone the length of the array to actually get our answer. But you know that when we have something sorted, and we are trying to search through something that is sorted, the binary search will be a better algorithm. And if you watch our last video, I strongly encourage us to go and look at that, where we talked about binary search. We solved the binary search algorithm. So we'll be applying that here now. So knowing that it is sorted, so for example, let's use this example. I've put the A, B, C, D. We have K, 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 and we have N. And then we are looking for, let's say, O, for example. So based on binary search, we divide it into two. So we have A, B, C, D, K, and we have K, 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 and N. So we ask ourselves, this where we are now, K, is it more than O? No, it's not more than O. So we know that O is definitely cannot be on this side anymore. So we focus on this. So we have K, 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 N. We divide it by 2 again. So we have K, K, K on one side, and we have K, N on the other side. We are checking, is this K, is it greater than O? No. So we know that definitely not this side. So we focus on this again. So we divide this into 2 again. So K and N. So K and N. Is K greater than O? No. So we know that definitely we are talking of N here. And then we could just say, is N greater than O? No. So we know that O is something that exists after here, for example. Let's say, so O exists after O. And O is, or whatever what we are looking for in this situation, O is more than our last element, which is N. And so at this point, we know that what we have to do is just to pick the first element. Because, you know, we are told if no such element exists that is greater than what we are having, the target, for example, which is O here, then we should pick the first item. So in that situation, A will be what will return. So basically, you see, instead of going through 10 items, we have just gone through 1 step, the second step, third step, and the fourth step. Basically just 4 or 5 steps. So imagine if it was 10,000, it means instead of going 10,000, and you know, this is very astronomical. So for example, if we had maybe 10,000, if we go the first time, we eliminate 5,000. So we are left with 5,000. We go the second time, we make it 2,500. We go the fourth time, or is it third time now? 1,250. We go again, it gives us 6, I think 7, 5. We go again, this will be 3, this is 2, this is, let's say, 8. We go again, this is 1, 6, 4. We go again, this is about 82, 41, let's say 20, let's say 10, 5, 2, 1, 0. So let's just say this. So you see, for something of 10,000, instead of going through it 10,000 times, we've just gone 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. We just had to go through 14 iterations for something that we actually have taken 10,000. That will have gone through 10,000 if we are going one by one. We just need to go through it 14 times. And that will be at the worst case if we don't find it up to the 14 point. So you see, the binary search is very, very applicable in many situations. So far we are guaranteed it is sorted. Like in this situation, we are told it is sorted in non-descending order. So that means it's going to be ascending upwards. So from A all the way to Z. So this is the approach we will just use. And at any point, so let's say, for example, we are given, let's use an example where we have A, B, C, 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 D. Let's just leave it as this, or E, let's just put it as this. And we are told what we are looking for, the target is C. So, you know, what we will just do with our binary, we divide it into 2. So we have A, B, C, C, and we have C, D, and E. So definitely we are asking, is this character C, is it greater than or equal to this? So if it is equal to, so I have gotten my match, sorry. So all I just need to do is, I've gotten this C, so I just need to keep, because we are told it can be repeating character. So I know that the next character can be C, so I need to keep going. For example, from this C, I go to this. Is this C? Yes, it's this C, so that's not what I'm looking for. Is this C? No, D. Definitely this is going to be my answer, because it's definitely, since it's sorted, it means that this is going to be definitely the next alphabet or character lexicologically that after C in this particular array. So basically this is the approach we'll use. Let's just go to LeetCode now and try and see how we can put this down. All right, so here we have our question, and so just like in our binary array, so I'll just have the left, let me have the right, let's have the midpoint. So the midpoint will be the left plus the right, and we can divide this by 2, and so we just go through it. I am leveraging on the fact that we understand what binary search is. So based on, please, I strongly encourage, if you don't know what binary search is, I encourage you to watch our last video. I tried explaining also in this video, but I think I explained it extensively in the previous video. So we have mid is equals to left. For every iteration, we have to check if left plus right. So, and what we just need to do is, if we know if the target, if we are at our target, so if letters at mid, so we know that we have gotten it. But you know, because there could be multiple, like the example I showed last, where we had multiple C's, even though C was the target, we need to keep going until we find something that's not. So we know we have gotten the target, so we are looking for the item after it. So we could just say, let's go through the letter, and we are asking if it is still target, then I want to keep going, because I want to keep checking the next. I want to check the next, and if at any point I find out that I have gone out of the bound, so like letters.length, then definitely I know at this point, let's say, I can just return my letters. So this means that C or whatever that character is the last. It is the match, but there was nothing after it. So if I will show an example, so let's say here, imagine in this place we didn't have this. Imagine we just had A, B, C, C, or A, B, C, C, and we are giving us C as our target. So when we divide it, we have C here, and we keep going C, C, but we're out of bounds already. There's nothing else. So it means that it could not find any match. And so we know that we are told if we don't find a match, then we now pick something, whatever that is put as the first item. So basically that is the same I'm just doing here. So I'm just going through it and say, okay, if I kept going and at a point I am out of bounds, then I just know that just go and pick the first character. Otherwise, so if it actually found something, like when we found it, then I know that that is what I'm just supposed to return. I'm just supposed to return that letter at that point, basically. So, but now what if we didn't find a match? So it means, for example, let's say our target is greater than the letters at that point. So we know that we need to move our left, and else we know that we need to reduce our right. Basically like the, so, but you know, now let's say we did not find a match. We didn't find a match. There are two scenarios to it. It's either I have searched all through and I didn't find a match, and I'm on the left side, that means leftmost side, that means I have gone out of bounds. I'm no more within the picture. Now we know that at this point, when it is out of the bounds, that it means that my left will have gone, either my left, if it is greater than every other thing, my left will have gone out of the bounds. So that means my left will have been greater than the letter's length. Now, and if this is the situation, then I know that what I'm to return is just the first item, because it means it doesn't exist. So it means I'll just pick letters, the first index. But if it found it within it, so it means that it could not find the particular character we are looking for, but it knew that there was another character that was after it. So that's where my left will be. So if I will show on the board here, if, just let me create some space here. So let's say we have this now. So let's just use the same example we are using, A, B, C, 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 and the target was D, for example. So if D was the target, we know that A, when we divide into 2, D is more than C, so it will come to this side, CC. We divide into 2, it's still more than 2, so we have just C. We divide more than 2, divide by 2, of course, the middle will still be C. So when we check C, C is still less than it. So my left will have jumped and come to the index beyond this. I know this is index 4. This will have been index 5 now. And now there is no item in index 5. So that is where it will have come out of the while loop. And at that point, we're just checking if my left is gone past the bounds. So I know that it means that the highest value in my letters is still less than my D, which was given me as the target. So that's why I'm saying then in that case, I just want to come and return whatever is the first item. But what of a situation where we have A, B, let's say C, 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 let's say E, and my target is, let's say, D, for example. So I divide this into 2. I have A, B, C. So definitely I know I'm not going with this, so it's going to be C, C, E. I divide it into 2. D is greater than CC, so it's going to be, we have just E. Now E is more than my D. Now, so what will happen is that the right will actually go back one step, but my left will remain where it is. So it means that my left is still on this particular index, which is index 5, I think. Now, so all I just need to return is just this E, because I know definitely this is the next character that will have been after my target, which is D, since D does not exist. So it means that my left actually knows. So for example, if my left will be where the next item or next character that is more than my target exists, and I can just return this. So basically I'm just checking if my left, if it's more than the bounds of the array, then I know that definitely it's more than every character there, and so I could just pick the first item. But otherwise I just return what is in my left index. Let's see what this comes out with. Okay, so we have an issue and it's saying letter. Oh, okay, so this is letter, sorry. It's letters, so let's run it again and see. Hope I didn't use letter anywhere else. Okay, so we are good. Let's submit and see if our algorithm is okay. So we have an issue. So here we are told that CFG, and we have the target to be G. So we know that G is out of the bounds. Sorry, no, GF. Okay, so G should have been here, but we returned J in this situation. So let's see, why will that be? So our target is more than the mid. We increment this and we reduce this, we return this. So let's see, left. We keep doing this. Okay, I will need to check, but okay, so we are returning, okay, it expected G, sorry, but we're returning F. It expected F, A, B, C, D, E, F, G. Okay, so this should have been the output, but we are returning this, since it, and the target was G, so it did not get the, so we are returning the left, but the left should have incremented to this at this point, but it's not. So what could we be missing here now? Oh, so see the problem. My right should have been letters.length. Wow, that should have been the last index. I'm so sorry. So this should have been the last index, and so because when I add my left and right, so how did it pass the first 3 tests? Those simple cases. Maybe because those ones are just, I'm not sure why how we passed this. Okay, this is just the first iteration, so it will work for this. This is also just the first iteration, so it works. So okay, probably that was why it worked for that. So let's do this and see. Okay, so here we have our solution. So we just use binary search basically, and we go through using binary search, and when we find a match, we just iterate to the point where we have the next character that is not matching our target. And if we did not, then we now know that it's either we return the first item or wherever our left index is, because where the left index is actually going to be the next character in the sequence. I hope we found this helpful. If we did enjoy this, please let's like, let's share and subscribe, and I will see us again in the next video.